I have a book coming out called The Infinite Resource, The Power of Ideas on a Finite Planet. And this talk is basically a short version of that book. A long time ago, Dickens wrote these words in the opening of A Tale of Two Cities. It was the best of times, it was the worst of times. And this pretty much captures the current discussion of what's happening on this planet. In a lot of ways, we're living in the greatest age humanity has ever seen, and you'll hear a lot about that here at Singularity University. But in a lot of ways, we're facing some of the worst risks also. So you see sort of highest levels of optimism in some parts of society and highest levels of pessimism in other parts. Now, at the opening of the GSP, I think you all got the challenge of finding a way to make the world better for 1 billion people. And there is no topic bigger than the ones I'm about to talk about, which is literally the fate of the planet and of human civilization, and the core question of, can we keep growing richer and better off without over-consuming and destroying the world that we live on? Okay? So is the future one of sort of utopias that are incredibly prosperous but also green, or is it a future like this? Who can name this film? Planet of the Apes. Very good. This is an easy one. They will get harder. All right, so let's start with the best of times. I was born in 1973 in Egypt, in a working class neighborhood like this. Okay? And when I was born, infant mortality in Egypt was 15%. So I had a 1 in 6 chance of dying before age 5. And so that's always given me a tremendous perspective. When I look back at where I came from and what life is like in America versus what life is like in my parents' generation, it's amazing that America is obviously such a better place. But it's not just a difference between cultures, it's a difference in time. Because there was a time, well, I should say in my parents' generation it was even worse. 3 of my father's siblings died in infancy, and 5 of my mother's siblings died at birth, right? But again, this is not just an issue of culture, because in the United States, in 1900, infant mortality was 25%, and in big cities, it was 1 in 3. In Chicago in 1900, 1 out of 3 children born died before their 5th birthday. So the change is striking. Today in Egypt, it's 2%, and in the US, it's 0.7%. Almost no metric summarizes the progress we've made better than that. You can pivot it another way and look at life expectancy, and you see that over the last half century, it's soared. The top line is the developed world, where life expectancy has gone up by about 13, 14 years, and the red line is the world as a whole, where life expectancy has gone up even more, and now it's at about 66, 67 years around the planet, where it was about 30 years of life was the average in 1900. Poverty has dropped. The fraction of the world living on less than $1 a day in the 1970s was around 1/3 of the world. And today it's down to just around 5%. So we've made huge strides, not just in the rich world, but in the world overall. Education, one of the most fundamental enablers of people to make a better life for themselves, has soared. So the top line is the United States, but here you see India and Ethiopia, the yellow and red lines, as 2 sample countries from the rest of the world catching up. This is on a log scale, but you see the ratio of how much schooling the average person growing up in the US gets versus how much schooling the average person growing up in Asia or Africa gets is shrinking over time, and that's a tremendous fundamental enabler of people. Connectivity is at an all-time high, something that you've probably heard Peter talk about. So mobile phones went from a technology that did not exist, practically speaking, in the 1990s to one that today reaches more than 3/4 of the world. So more than 4 billion people have access to a mobile phone. And if you count people who have a friend with a mobile phone, that number is even higher. And the internet is close behind that. So again, it's gone from a technology that almost didn't exist for all effects and purposes in 1995 to one that has 2 billion users today and is rapidly growing. So we're living in an age of sort of the greatest, the least poverty, the least hunger, and the most interconnectivity of all time. That's had other consequences. As people have grown richer and as their ability to communicate has gone up, they've demanded more control of their lives and more participation in the political process. So today, the fraction of the world that lives in a democracy is also at an all-time high. And there's a clear connection there. There's a lot of theoretical work linking levels of education in a country to levels of democracy in a country. And there are many theorists who would tell you that once a nation passes a certain level of average education, democracy is fairly inevitable. And we perhaps are seeing some of that with the Arab Spring now. Perhaps more surprisingly to American audiences, at least, is that the world is becoming more equal. So this is a distribution of income in 1970. So it's a scale across the bottom. From left to right is poor to rich, and from top to bottom is how many people live at that income level. So you see in 1970, the world had a lump sort of off towards the left, and then a long tail of people getting richer off to the right. And in 2006, the last year for which we have great numbers, the income distribution has both shifted to the right, people have gotten richer, but it's also become more equal. It looks more like, let's see that again. So in 1970, you have kind of a big lump of people living on between $1 and $2 a day. Those are the two vertical black lines. And in 2006, we've taken the people on the far left in poverty, and they've moved up in income tremendously faster than the people on the right. The world, on a macro scale, is getting more equal in income. Okay, so best, richest, most democratic, but best off, etc., but also potentially the worst of times. So let me tell you a story. On Christmas Day, 2005, I woke up before dawn in Guatemala. I got up and I hiked through the jungle to get to this structure. This is Temple 4 in the Mayan city of Tikal. And in 900 AD, this was the tallest structure in the Western Hemisphere. In fact, it was the tallest structure in the Western Hemisphere until about 1900. It was a skyscraper, and it was in the middle of a giant city inside of a civilization of about 20 million people. That morning, when you looked out as the dawn came up, it was an amazing sight. Everyone, it's a jungle, there's howler monkeys, there's giant roars. You feel like you're on the set of Jurassic Park. And the structure just underneath the sun in this picture is about 1 mile away from where I'm standing. But this was not jungle 1,000 years ago. This was the heart of a metropolis. But when Westerners found this for the first time in the early 20th century, all of that had been reduced to this. If you walk through a Mayan city right now, what you find is not so many great tall buildings. You find a lot of mounds. They look like hills, but they're not hills. This is the ruins of 1,000 years. These cities were literally abandoned for 1,000 years. The Mayan population dropped by a factor of 10 from its peak to what it was when Spaniards came. So what happened to the Maya? Well, the Maya were at the peak of their success. They're at the peak of their population. And to feed that population, they had to chop down all the trees around them to turn that land into farmland. In so doing, the soil to erode, they removed the ability of trees to capture water and turn it into rainfall, which exacerbated drought. They were hit by some climate change of a global variety as well that also brought drought. And what that meant is that they exhausted their fundamental energy source, which was food. Food is the first energy technology. Without food, you can't run your civilization. And the Maya ran out of that, and that led to more conflict in their society and eventually to an utter collapse. Okay? Could that happen to us? Well, the number one energy source for humanity is fossil fuels, and none is more important than oil. In the 1950s, a fellow named M. King Hubbert predicted that we would see oil production in the US eventually peak and then drop. He did this in a very simple way. He looked at data from any given oil well. You can see that it starts off with a high flow, it goes up and up and up, and then eventually the field underneath it is depleted, and it goes down and down and down. So his methodology was simply, I'm going to sum up those curves of production for an entire country and see what happens. And he predicted that the US would peak in oil production around 1970. No one believed him, essentially. But here's what happened. Oil production initially rose and rose and rose after his prediction. But then in 1970, it actually did hit a peak that he predicted, and then it went down and down and down. And it is somewhat resurgent. In the last 2 years, we have seen in overall oil production in the U.S., but that still has the U.S. producing half the amount of oil that it did in 1970. Right? Well, the U.S. is just one place, it's just one country. It's not the world's biggest oil producer. Oil is a global commodity. Well, Hubbard also predicted that on a global scale, we would see oil production peak around the year 2000 using the same methodology. And for a long time, people thought he was crazy, and production went up and up and up. Then it kind of plateaued, went up more slowly. And then for the last 8 years, since 2004, it's been effectively plateaued. So oil production has changed by about 4% over the last 8 years, which is what used to happen every 2 to 3 months. That's how fast oil production was gaining in the 1950s. So let's look at that more closely. So since 2004, the red line is the price of oil, and the black line is the production of oil. So I'm a capitalist. I worked at Microsoft. I can't deny it. The thing I know about corporations is they exist to make money. In the presence of a very high price for one's commodity, one has every incentive there is to produce more of that commodity. And so far, oil producers have not been able to keep pace with demand, and that's why prices are so high. They do fluctuate. You see in 2008, the price came down. That's because of a recession, right? And there's actually some data suggesting that the peak in the price of oil was one of the major contributors to the global recession, and not just financial shenanigans. Now, there is plenty of oil in the ground. The problem is not how much oil is in the ground, it's our ability to pump it out. We have gotten better and better at pumping oil out of wells. It used to be that an oil field had a maximum recovery of about 30%. You could get 1/3 of the oil out of a field, and after that it was under too little pressure to get the rest. So we've gotten better and better at increasing that amount by pumping in high-pressure water, pumping in steam, pumping in detergents. But fundamentally, you can't take a field past 100% recovery. And the problem is that all of our holding on to current production levels has been by forcing more and more oil out of these fields. They're getting more and more exhausted. And the rate of discovery of new fields has not kept pace with the rate of production. The black line is production, and the bars below it is the rate of discovery. So the whole way that we're keeping up with demand is just by kind of squeezing these existing fields for more and more of the oil that's in them. And this poses some severe risks for us to come. People talk about peak oil. We might basically be in peak oil right now. We might not. There are a lot of economic incentives to try to pump oil production up further, but again, we've been more or less at a plateau since 2004, 2005. So oil is not the only resource that is potentially scarce. Water is life. We use 70% of the world's water for agriculture. People talk about conserving water, off the tap, taking shorter showers. That is not the major source of water. Water is predominantly a resource used to grow food. Okay. Can anyone name this body of water? Very good. Almost no one ever gets this. Oh, okay, back there. All right, Federico. Very good. Yes, that's right. The Aral Sea is a freshwater body. It was the 4th largest water body on the Earth at the time of this photo, 1989, from NASA. Here's what it looked like in 2003, and here's what it looks like today. The Aral Sea, A-R-A-L-C. The Aral Sea is between Kazakhstan and Uzbekistan. And what happened to it is that the USSR in its dying days, and then later Russia, basically diverted all the rivers that fed into it and pumped all the water out of it to grow food and other agricultural commodities like cotton. And so now, this sea that took tens of thousands of years to fill up is gone, effectively. The area around it is dotted with the bones of fishing villages. There's whole villages with boats dried up on sandy bed, and no economy, no fish, and no water to keep growing those crops. Yep, thank you. So go pull it up and zoom in. Now, The ROC, as I said, is between Kazakhstan and Uzbekistan. For the fraction of people here who don't live near that, it might seem very academic, but this is not just a phenomenon of one place. It's a phenomenon worldwide. And right here in the United States, we have this thing, the Ogallala Aquifer. This aquifer is an underground reservoir of water that is filled with the melt of glaciers that retreated 13,000 years ago. It has a refill time of between 10,000 and 20,000 years is how long it will take to refill this. And since 1960, we have pumped nearly half of the water out of it. On current pace, this will be entirely drained by 2050. And in fact, in some areas, like northern Texas, the wells that go into this aquifer are running dry right now. And so farmers who are pumping this water out to grow crops, grow cotton, are no longer able to do so. And if we run out of water, agriculture fails. So this is actually a global civilization risk. All right, there's a saying that there's plenty of fish in the sea. That was once more true than it is today. We have overfished the deep oceans and more than half of all fish species that humans consume are fully crashed or tremendously overconsumed, and there are basically no fish species left that we know of that are underexploited in the deep ocean, if you will. In fact, you'll see phenomena like about a decade ago, 15 years ago, we discovered this species called orange roughy. We'd known the species, but it became suddenly commercially viable, and those went from being not humans at all to being nearly crashed in a span of less than 20 years. Okay. Forests. The Economists calls the world's forests the world's lungs. They're responsible for about 20% of the oxygen that we breathe. They're also incredibly important in the moisture cycle. Forests capture a tremendous amount of moisture passing, turn that into cloud, and turn that into rainfall, so we depend on it. In antiquity, about 2/3 of the land area of the planet was covered in forest. Today, it's about 1/3. And primarily, that difference, that 1/3 of the world's land area, or half of the original forests that are gone, is because of agriculture. Agriculture is the #1 cause of deforestation. Pretty much we chop down forest or we slash and burn it into farmland or turn it into grazing land for cattle. And while we've made good strides in rich countries, so North America and Europe have reversed the trend of deforestation and are holding steady or even slightly increasing, in the tropics, the trend is continuing, and we're still chopping down forest in Brazil and Indonesia and other areas where we really would like not to be. And perhaps the largest global risk is climate change, global warming. So I'm going to show you what the temperature looks like since 1880. Okay? This is the temperature record compiled from nearly 100,000 separate sensors and more than 1 billion data points from 1880 to today. And what you can see is that temperature in degrees Fahrenheit has risen by about 2 degrees in that time. You also see it's not a smooth transition. There's no guarantee that any year is warmer than the one before it. It's a jagged line that jumps down over time. But if we look at kind of the overall trajectory, we'll see that the shorter the time period, the closer you get to the present, the faster the change is happening. So that change is accelerating. And it's because of the CO2 we're pumping into the atmosphere. Records ice cores drilled from Antarctica and Greenland that go back 800,000 years, and recently longer than that, show a close coupling of CO2 levels in the atmosphere and temperature for the last 100,000 years. And now, if you look at that blue line, we're at CO2 levels that we haven't seen in any of these ice cores. If we go back further and look at sediments from the bottoms of lakes, we find that we're at CO2 levels that haven't been seen in the lifetime of our species. We haven't seen these levels in a million years. And in fact, the last time CO2 levels were this high, there were no ice caps, and seas were dramatically higher. Now, that's still a slow process. It takes a long time to melt the ice caps, but it's a process that's starting right now. Now, not everyone is a numbers person. Some people like more kind of visual or visceral evidence. So let me show you a couple other examples of what's happening. This is the Bear Glacier in Alaska. This is a picture of it in 1920, and here's a picture of it now, 2005. Okay? This is the Peterson Glacier, also in Alaska. Here's a picture of it in 1920, and here's that same area right now. It's almost unrecognizable. Watch the mountains, watch the profile of peaks there. It's the same place, but you wouldn't know it any other way. Okay, that's one sign of what's happening. And that ice will eventually turn into higher sea levels. Now that will take a while. Sea levels will rise between 1 and 2 meters this century, so 3 and 6 feet. That's actually not the biggest threat that we have. The biggest threat we have isn't a threat towards the end of the century. It's a threat that's starting right now. And it's a threat to our production of food more than anything else. And that's caused by more extreme weather, more heat, more drought, and more fire. Okay? In 2003, Europe suffered its worst heat wave since 1940. Its worst heat wave in nearly 500 years. 70,000 people died. Ukraine lost 3/4 of its grain harvest. About a quarter of the forests in Portugal burned. In 2009, China was hit with its worst drought in more than a century, a 1 in 100 years level drought event. In 2010, it was hit by another 1 in 100 years frequency drought level event, which doesn't quite add up. Wells that had provided water since the 16th century stopped. Now this happens because warmer air can trap more moisture. More moisture up from the ground, and then it can deposit it in other places. So while we see drought increasing around the world, we also see incidents of flooding increasing because the moisture we do get ends up more concentrated. So in 2010, after that air picked up all that moisture away from China, it deposited it in Pakistan. And an area twice the size of the state of Texas, an area larger than Germany, was underwater in Pakistan. There are no recorded floods in history as bad as this in that region. Then later in Russia, we got another massive drought and another massive heat wave. In 2010, 55,000 people died of heat in Moscow alone in the months of July and August. And then last summer, in the U.S., we had one of the hottest summers on record. In the American South, in Texas, we had the driest 10-month period ever on record, and we had 4 million acres of forest in Texas alone burn. Normally, in a normal year, 1 to 2 million acres burns across the entire U.S. in a summer of fires. This is a dramatic kind of off the scales. And now we're looking at this summer, the hottest May on record on the planet. It was May. We don't have the final numbers in for June yet. And now we have a massive heat wave going on most of the United States, fortunately not the West Coast. So there are severe challenges that are happening right now. And I mentioned this is a threat to agriculture. When these fires hit Texas, Texas's wheat crop dropped by about half. Texas's hay crop was basically destroyed. So when you have extreme weather, it poses a real threat to, again, that most fundamental energy source of humanity. Now, even if the temperature wasn't a problem, there are other problems with the CO2 production, which is that CO2 hits water and gets turned into carbonic acid. Carbonic acid is not necessarily the worst thing in the world. You've had a little bit of it anytime you've had a carbonated beverage. Your body produces it when you exhale. When you produce CO2 in your body, it gets turned into carbonic acid before you exhale it through your lungs. A little carbonic acid is not the worst thing, but a lot of carbonic acid is. It affects the ability of anything that builds shells. So calcifiers, coral reefs, for instance, which do fine at low levels of carbonic acid, do progressively worse and worse. And current projections are that about half of the coral species on Earth will not survive the degree of acidification of the oceans that we have coming up. So all of this assumes sort of linear warming, but there are other exponential processes at work. In particular, there's a huge amount of buried carbon frozen in tundra and the seafloor that poses a huge risk of explosive release. So this is tundra in Alaska. Actually, it was tundra. Now it's melting. Now this is what you call a thaw lake, which is that it was once completely frozen, now it's not. And as this lake thaws, frozen vegetable matter that was there starts to decompose and give off methane. And methane is a tremendously powerful greenhouse gas. You can see it here. This is a methane bubble that is formed underneath the ice. It's about 1/2 meter wide. How do we know it's methane? Well, methane is natural gas. If you poke a hole in this bubble and light it, it will burn. And when it gets into the atmosphere, methane has, in its first few years, about 100 times the warming power of carbon dioxide per molecule of carbon, and over the long term, about 30 years. And there is a huge amount of buried carbon in the world. The world's forests and soil and tundra have about 3 times as much carbon in them as the atmosphere does right now. The world's oceans have another very large reservoir. So if any of this did explosively into the atmosphere, we're looking at the ability to take the warming effects that we currently think will reach us around 2100 and accelerate them so they reach us around 2020 instead. That's not something that we want. And there is this risk of kind of these positive feedback loops of high temperature thaws the permafrost, which produces more of that, which leads to more temperature, which leads to more permafrost thaw. This is not just a theoretical possibility, it's happened. So 13,000 years ago, when the last ice age ended, we ended the period called the Younger Dryas and soared by about 10 degrees in the span of a couple decades. Okay, so this has happened on planet Earth before. We know that climate can change extremely, extremely rapidly. And today we see that the largest reservoir of methane on the planet, which is the undersea sediment, frozen methane slush in the bottom of the Arctic, is starting to go. A Russian expedition in December and January, just recently, found kilometer-wide plumes of methane bubbles rising up from the as the methane hydrate at the bottom, that's kind of a frozen slush, has started to melt. So if we sum all of this up, all the ways that we're sort of overusing, overpolluting the planet, people like to talk about what is our overall footprint on the world. And a group called the Footprint Network has tried to calculate this. What they've found is that currently we're not using just one planet Earth's worth of resources, we're using about 1.5 planet Earth's worth of resources. And that if everyone in the world lived the same lifestyle as an American, we'd be using about 5 planet Earth's worth of natural resources. I don't have 4 spare planet Earths. Any of you? I didn't think so, but if you do, come on, let's chat. So the problem, many would say, is growth. Who can name this city? Shanghai. Hong Kong was a good guess, but it's Shanghai. So Shanghai was little more than a fishing village on the river 20 years ago, and now it is a mega metropolis. And that has come with tremendous growth, tremendous opportunity and benefit for the people of China and the people in this region, but it's also meant the use of more steel, more carbon, more water, all of the things that end up producing externalities. So an increasing number of people say that we have to stop this, that this sort of economic growth comes with negative consequences, and so the growth itself has to be paused. Bill McKibben, who's a wonderful environmentalist, wrote in his book Earth that growth is a problem. A fellow named Paul Gilding, another prominent environmentalist, wrote that we have to end shopping, and the consumer economy basically has to end if we're going to save the planet. A fellow named Richard Heinberg at the Post-Carbon Institute wrote a book called Peak Everything. The subtitle is Waking Up to the Century of Declines, that it's not just oil that's going to peak, but as a result of that, and for similar reasons, all minerals, wood, water, etc., and we just have to get ready for a world where we just can't use as much, we have to use less. This, unfortunately, runs into some basic issues, which is that the world is getting richer and is still growing in population, and so demand is rising. Over the next 40 years, we expect the demand for water to go up by half, food to go up by 70%, and the demand for energy to double. So we can't just say, oh, we're going to use less, and ignore the fact that people want more, people are trying to use more. And most of that demand increase is not going to come from the West. Demand is not really rising in the United States or Europe or Japan. It's rising in China and India and Africa. That is where most of the demand is coming from, and it's going to continue to for some time. And while demand is rising there, and that's where the growth is coming from, these are the places that are rising out of poverty. So there is no way that you could say, oh, the West got rich using these resources, but I'm sorry, rest of the world, I'm sorry, bottom 4 billion, bottom 5 billion people, you can't do the same. That wouldn't be just, even if it were practical, even if there were a way to do it. Now, the good news is that we have faced situations like this before. We've been warned of problems like this before. Years ago, Thomas Malthus wrote that we were doomed, essentially, because population increase was exponential. So demand and consumption was exponential, but the production of the most important resource, food, was only linear. So in his view, the red line that was consumption would always outpace the green line that was production. He thought that England, his home country, would face massive die-offs in the early 1800s, and he was wrong. In 1968, Paul Ehrlich wrote The Population Bomb, widely quoted today, highly respected, and he opened that book with the sentence, "The war to feed humanity is over. Billions will die. At this late date, nothing can prevent a rise in the overall world death rate." And he was wrong. He thought we would see massive famines in the 1970s and an increase in global deaths, and in fact, the rate has plummeted and the death rate has plummeted. And the best-selling environmental book of all time, The Limits to Growth, in 1972, also massive problems. And these guys, they speak to a geek's heart, because what they did was they created a computer model, they plugged in different variables, and they ran their model, and their model said that we were doomed. What it said was that economic growth, more wealth, all meant more pollution and more consumption of non-renewable resources. And that eventually would take the world beyond the limits of what it could provide and into collapse. But the collapse predicted is not manifesting yet either.